You everyone today, and thank you everyone who joined us today. And today is we are talking about Windows, Linux, and scaling cloud-native .NET application with Traefik. I had this finally opportunity because I started my career as a .NET developer, and when I shifted my focus to the DevOps side, I don't have enough time to know what's happening in the .NET space, and I'm really excited today what it is .NET applications are and what are the happening inside there. And thank you very much for joining us today. And this is session on around what's new in Ranchers 2.6, Traefik, how to run cloud native .NET application on top of Traefik, what Traefik it is, what it's fit for. And today my guest is Hayden Barnes from Rancher team. I will show you what's new in the Rancher 2.6, and also the Jimmy Phillips. He's a very wonderful speaker around .NET technologies. They both are, thank you very much for spending time with us today and helping us understand what's happening in the Windows containers, in the Linux container side of things, and what is the Ranchers doing in their cloud native applications, what Rancher 2.6 bring to us as the audience. And without wasting your more time, now I switch back to the Haydens. Introduce yourself to my audience and start proceeding for the session.
Great. Hello, everyone. My name is Hayden Barnes. I'm an engineering manager here on the Windows on Rancher team at SUSE. I'm probably most known for my work on WSL, and I think that's how we got to know each other before I moved into the cloud native space. And I'm going to talk a little bit about WSL and my philosophy on cross-platform development. And then we're going to switch to my colleague, Jamie Phillips. He's our engineer. If you want to say hi real quick, Jamie.
Hello, everyone. I'm Jamie Phillips. Been a .NET developer for a long time before coming to SUSE over to the Rancher on Windows team.
So we're going to talk a little bit about WSL, kind of this emerging cross-platform world around desktop that's now reaching cloud native. Kind of moving up the stack. And let's take a look at the agenda for today. First, we're going to talk about this new era of cross-platform. And I just left it at cross-platform because it's not just development, it's also DevOps, production. It's just this new space where we have Windows that can run Linux. We have Windows containers powered by Linux worker nodes. It all seems to be happening side by side, complementary to each other. So we're going to talk about that in the context of WSL. Then we're going to talk about cross-platform going cloud native, and that means both Linux and Windows containers, and how we're accomplishing that at Rancher with Rancher and now Rancher on RKE 2 with our latest innovations there. We're also going to cover a demo and then do a quick Q&A. So this is the stuff that I get really excited about. I've always been a huge open source geek and cross-platform nerd. I enjoy running all kinds of operating systems, tinkering with them, everything from Linux when I was 15 to BOS, to classic Unix operating systems. I enjoy that. And we're now in this heyday where you don't have to pick one operating system. So on any given day, I touch Windows, I touch Linux, I touch Mac OS, and that's just on my desktops. I also have Android and iOS devices, all of which are running different operating systems. In terms of Linux on Windows, that evolution started, of course, with the native virtualization for Windows Hyper-V. Then came Linux containers on Windows, which some of you may remember. And then back in 2016, we saw the introduction of Windows Subsystem for Linux, WSL. That first iteration of WSL, of course, was a binary translation layer. It took Linux ELF binaries and translated those Linux system calls in the binaries to NT system calls. It worked pretty well. And over time, the team was able to develop probably close to 95, 98% binary compatibility with Linux binaries using a technology that came out of Microsoft research called Pico processes, which are basically tiny micro VMs for individual applications. But that technology kind of reached its pinnacle and transitioned to what we transitioned to with WSL2 was a lightweight virtual machine powered by an actual Linux kernel. Now, when this first debuted in 2019, this blew everyone's mind. A Linux kernel working inside Windows to provide this lightweight terminal environment for developers, DevOps engineers, system administrators in Windows. It is a upstream Linux kernel that has had some minor modifications done by the Microsoft kernel team. And Microsoft does have a Linux kernel team, and it provides much, almost 100% binary compatibility with Linux applications. With the exception of some caveats, you're able to basically run now pretty much anything on Linux on WSL2. There might be some workarounds for some projects that require things like systemd and that kind of thing, but in general, it's a much more powerful platform. Then on the Linux side, of course, we also have Windows VMs, and any Windows VM you spin up in the cloud is probably powered by Linux. So we actually in the cloud have millions of Windows VMs running on top of Linux, and then in the cloud native space, when it comes to containers, we now have Windows containers on Kubernetes, originally powered by Docker, and now we'll get into powered by Containerd. But even those, have to have Linux control planes and worker nodes. So Windows on Linux, I consider that Windows on Linux still, because you're running Windows, but you still require the Linux components. But in addition to Linux on Windows and Windows on Linux, we're also seeing this proliferation of cross-platform tooling. So if you're a developer or you edit YAML, you might be familiar with Visual Studio Code. That's available for Windows, Mac, and Linux. If you're familiar with eBPF, which is a networking tool for Kubernetes, originally on Linux, that's now coming to Windows. So you'll get consistency across both. Windows now ships with OpenSSH there. So you have an SSH server and client. Of course, everyone's familiar with .NET Core. Now it's just .NET being available for Linux. And another tool I wanted to highlight now was Rancher Desktop. Rancher Desktop is the desktop application for Rancher, which is now available in preview for Mac and Windows. And the exciting part is that the Windows application is powered behind the scenes by WSL. And Rancher Desktop, unlike Docker Desktop, is fully open source and much more flexible in terms of which version of Kubernetes you're running. And it's rapidly approaching feature parity with Docker Desktop. And if you're looking for an alternative for Docker Desktop, we really hope that Rancher Desktop is something you consider and will be a viable option for you. So I just want people to start thinking about this new era of cross-platform. It starts on our workstations as developers, as system administrators, as DevOps engineers, but it doesn't just stop here, it goes to the cloud too. Real quick, before we move further up the cloud, I wanted to give a brief update on WSL2. For those of you who may have tried WSL early on but haven't come back to it, or just want an update on the latest features. Of course, WSL2 is that lightweight VM. It's a Linux kernel maintained by Microsoft. The average boot time to get, from the time you launch terminal to a bash prompt is 2 seconds. You of course have access to your C or D or E, however many drives you have, automatically mounted inside WSL2, just like WSL1. WSL2 is a lightweight VM, so it doesn't. It has separate memory, but it has automatic memory handling built into the WSL kernel. That's one of the tweaks that Microsoft provides, is automatic memory compaction. And like WSL1, you can install your choice of Linux distros directly from the Microsoft Store, and I'll show that in a little bit. One of the more recent innovations on WSL2 is the introduction of WSL-G. WSL-G is a new GUI layer for WSL. So, when WSL started, it was just a terminal. And it was the old legacy terminal too, the classic command prompt PowerShell terminal. That's since been updated with the new open source Windows terminal. So we now have a modern terminal experience for Windows, but we now also have WSL-G, which enables you to run Linux GUI applications on WSL. And that is powered by a Wayland shim that connects through to the native RDP functionality built into Windows. It's fairly seamless. It supports both X and Wayland Linux applications. So you don't have to worry about, is this Wayland, is this X? They're both supported. One of the neat features I like about it is that it automatically adds, GUI app shortcuts directly to your Windows Start menu. So just if you were to install a Linux GUI app and have that application automatically show up in GNOME or KDE in your menu, it's now going to show up directly in your Windows Start menu. So the lines here are getting very blurry between operating systems. Some other advanced features of WSL2 that are coming or have arrived recently, direct drive access. So the ability to mount drives directly in WSL2 is super helpful if you are using WSL2 with externals, with extended storage. You want to provision, direct database access. So one of the caveats of WSL is that crossing the WSL Windows barrier sometimes introduces a bit of a performance hit because you're moving from one file system to another file system. But if you're doing a lot of work and need direct drive access to churn lots of data, that's now available. One reason you might need to churn through lots of data is you are doing things like GPU compute. And that is another feature that's now available. NVIDIA, CUDA is now supported. Intel is supported. And there are plans for additional GPU compute platforms coming. So if you want to do AI/ML on WSL2 and have it churn through a massive data set, mounted directly on a internal SSD, that is an option. One of my favorite features, being the operating system nerd that I am, is WSL2 now has KVM acceleration with nested virtualization, which means you can then not only run Linux on Windows, but then within Linux, you can use KVM and pass through, all your nested virtualization, all your CPU hardware flags, and run, either Linux containers or Linux VMs inside WSL or other operating systems. So I've tinkered with a few. If you follow me on Twitter, you've probably seen me run things like Haiku or macOS as an experiment, not in production, because we wouldn't want to, run into any EULA issues there. But it is possible to, work with those operating systems. I even think I got Windows 95 running at one point just to see what it was like. So there's a lot you can do. And the story I tell around WSL in general is that WSL is what you make of it. And you have basically this Linux environment on Windows with all these cool cross-platform functionalities. And if you're coming from Windows and want to, leverage Linux, have that opportunity. If you're a Linux admin and you're issued a Windows laptop at work, you can now still get right back to work with Linux and work seamlessly and have both Office and Linux side by side. So one thing I wanted to show off real quick was you can now grab OpenSUSE Tumbleweed directly from the Microsoft Store. So I was going to show that really quick. Let me show my whole screen. Share my entire screen. Share. Hide that. All right, so you should see my whole screen. Yes, I'm running Windows 11. I'm on the beta channel just because I need to be able to work on the device, but I found Windows 11 to be super stable. I am here in the Microsoft Store. If you're looking to get started on WSL, you first need to enable WSL. And the easiest way to do that is to open PowerShell and do wsl.exe -- install. Now this works for recent versions of WSL, for recent versions of Windows. If you're on an older version, you may still need to go to Windows features or use PowerShell. There's some PowerShell commands in the docs you can run to automate it. It won't work here now because I've already got it installed, but getting WSL enabled is as easy as wsl.exe -- install. That'll enable WSL, pull down the necessary enable the Hyper-V component, then install the latest WSL kernel and the WSL-G graphics layer as well. Now it won't work here because we've already got it installed, but I can show you wsl.exe -- status. And you'll see here that my default distribution is OpenSUSE Leap. We're on WSL 2. It was last updated on 7.7. I've got automatic updates turned on, and we're running kernel version 5.10.43. With wsl.exe, you have a lot of options to configure WSL. This is how you can mount those physical disks. You can export and import images. That's a great way to make backups. Manually sideload distributions, either from a rootfs tar file, or you can also, there's some distros that are provided as AppX. If you're a Windows developer or system administrator, you may be familiar with the AppX format. But let's install Tumbleweed here. So for those of you who aren't familiar with the OpenSUSE distribution of Linux, OpenSUSE, see, it's already done. That was fast. OpenSUSE comes in a couple different flavors. There's Leap, which is the regular release cadence distribution. And the interesting thing about that is that OpenSUSE Leap 5.15.3 is binary compatible and built from the same source as SUSE's enterprise distribution, SUSE Enterprise Linux 15 SP3. So they are binary compatible, and you are basically getting a enterprise grade operating system for free with OpenSUSE. Now, OpenSUSE Tumbleweed, on the other hand, is a rolling Linux distribution. So you will always get the latest packages. Now, the nice thing, what I like about OpenSUSE Tumbleweed is that because OpenSUSE does so much internal QA and has automated a huge amount of QA processes, I've actually never run into an issue on a rolling distribution with OpenSUSE Tumbleweed the way I have with some other rolling distributions. I won't name them, but at Arch, and don't come after me, Arch people. But I like having the latest packages, and we will open OpenSUSE Tumbleweed here, and I'll show you. Give that a second. Figure out where it went. Oh, there it is. It's back there. Okay, so I have my, this is Windows Terminal, by the way, and I have the new Windows Terminal set as my default console. This is a new feature where you can set either the legacy legacy Windows console or the new Windows Terminal as your console. I have the new Windows Terminal. It's great. It's open source. It's fast. We'll configure OpenSUSE Tumbleweed real quick. We'll accept the terms, set our username, and we are good to go. So here we are at the prompt for, or the shell for OpenSUSE Tumbleweed. I want to just show you how fast this opens. I'm going to close it. I'm going to close this too, close all. All right, that just booted OpenSUSE Leap. And now we're going to boot OpenSUSE Tumbleweed. Where did it go? It did not register. Huh. That is interesting. It wouldn't be a demo without a small bug, which is fine. But it, I just wanted to show you how quickly it opened. And then here we're going to update our packages, and you'll see we're pulling from OpenSUSE Tumbleweed. And let's see. We're going to get the latest packages. And there we go. So we've all seen packages update, but you're always going to get the latest on OpenSUSE Tumbleweed, which I really like. So, I encourage you, if you've tried WSL before, maybe before WSL 2, and ran into some issues, give WSL 2 a try. If you're looking for a stable rolling release distribution with the latest packages, I strongly suggest OpenSUSE Tumbleweed. You can grab those directly from the store. Tumbleweed is also there. Leap is also there. 15.3 is the latest. 15.2 is there if you have any legacy needs. And yeah, so you can also, if you have any questions, you can always reach me on Twitter at Unix Terminal. And really what I want you to be thinking about is, especially now as we transition the conversation to going from cross-platform on our workstations to what cross-platform in the cloud means. So I really want you to be open to the possibilities. We're here in an era where we're running Linux with a Linux kernel on Windows. We're deploying our Windows VMs in data centers powered by KVM. Really where we're going to go next. And I think one of the places we go next is a place, as in cloud native on Kubernetes, where our Linux and Windows workloads work side by side, and I think Rancher is a great platform for that to happen. and we're going to do a demo now. First, we're going to talk a little bit about Windows codes working side by side further up the stack. And with that, I'm going to pass off to Jamie here in a moment. Let me get that slide deck back up and running for you. Give me one moment. Stop presenting. Switch. Jamie, about ready for me? Cool. So let's go here. Let's get really excited about this stuff, and I'm excited on to provide it to developers. I'm excited to provide it, in the cloud, and that's why I do a bit about Windows containers on Rancher.
Okay, so I don't know how many people here have used Windows containers or have started using those. So those kind of debuted back in Windows Server 2016. There's lots of things kind of happening, and there's lots of different iterations Microsoft has kind of went through. But as we've kind of gotten to Server 2019, they've kind of got a good set direction. They've got multiple base images you can now use that have different purposes. So here in the center, they have the SAC or the semi-annual release channel, and then they have LTSCs, which is the long-term or support channel. So they kind of have these two different options along with multiple image bases. And that's something that you kind of have to realize when you're working with Windows containers, is that you have different choices for what you need API support for your app. And then you have different versions of Windows based on certain features you need, which that's becoming less of an issue. 16 came in with container support. You started getting these multiple base images, trying to figure out what you need for your different types of applications. And then we've looking forward to what's coming with Windows Server 2022 AC channel. They've announced that a few months ago. It's kind of going to as being a long-term support along with 2019 until its end of life. 2022 is going to have the 5 years active plus 5 years of support model. I'm sure there'll be extended support that you could probably purchase. And then they have moved a lot of their stuff off of Docker Hub to their own MCR, and they kind of proxy through there. And then a big thing that's coming with 2022 and Kubernetes 1.22, at least in a beta form, is the host process containers. So now we're going to start having the ability to have a little bit more Linux parity with Windows containers, where we can launch a container that has access to the host, much like a privileged container in Linux. And then that way you can run things like CNIs as pods, which you currently can't do, right? So that'll give a lot more flexibility for deployments and things like that. I mentioned those earlier. So there's multiple versions of Windows, right? There's standard. So with standard and data center, you should have pretty much full support. And there's other limits that you'll need to go look up, but we support standard and data center right now. We haven't tested IoT, but I'm sure that's going to be a thing that we're going to test. I'm pretty sure that's on everybody's list. As far as like desktop development goes, you have to use Windows Pro or Enterprise currently right now with Docker Desktop for building your Windows containers. Rancher Desktop, which may or may not have Windows support, it's been on their GitHub. There's lots of requests for it. One of the goals of it is to work on home. Now, I don't know for Windows support if that'll be possible or not. That's really dependent on Microsoft and some of the HNS stuff that's kind of got to happen, which for the most part's there with WSL being able to work on home. So, so you'll need Windows Pro or Enterprise, and just realize that on the desktop, those containers are not tied to the version of the operating system that you're running on. They use Hyper-V isolation. Whereas when you're trying to deploy to a Windows server, you can't deploy a 2004 version of server on 2019, and you can't deploy it on 2022. I mean, you're going to kind of be able to. It's not something that's kind of supported right now. So, so you're kind of locked in once you pick a server version of which version of container you need to build. So you can do that from your Windows 10 just fine. Just know that that is a different model. And so when you start getting into your DevOps and your CI, you're going to need multiple versions of servers to build your Docker containers for which server versions you're going to target, right? So that's one nuance that's kind of out there. Also realize that Windows 10 needs a special version of Windows Server 2022 container image if you want to build 2022 images on Windows 10 right now. When you move to Windows 11, that's no longer an issue. So they have a stopgap solution out there for that. And there's a blog post on the Windows Server team for that, which I can tweet out at the meetup to get that link out there, or post it on the meetup page. So that's kind of what's there with Windows containers. The base images, there's server core, which is very straightforward. That's your smallest set of what would be considered a Windows Server API base. There's Nano Server, which doesn't ship with PowerShell or hardly any Windows APIs. I think it's 64-bit only right now too. And so that's the recommended for .NET Core. That is also your smallest image. But if you're going to do full framework app or anything like that, you're going to be on Windows Server Core to start with. And then depending on what API surface your app needs, you might have to step up to a bigger image, Windows Server. And if you have any reliance on any desktop type stuff, like say GDI libraries for your ASP.NET app or something like that, then you'll need to use the Windows base image. The Windows base image does have one caveat, which is it is limited to 10 IIS connections. So if you're serving a web app from that, then you'll probably have to scale out on that one. And that's just a limitation of the SKU. So that got clarified. There's some confusion around that one. I now know the details around that. So that's some of the nuances there. As far as what we've done with Rancher and RKE 2, Windows containers were introduced with RKE running Flannel as the CNI, running on Docker and Rancher 2.3. As it's progressed, we've added in things like monitoring and logging support. And then we have a Rancher agent that runs that helps Rancher be able to manage your cluster. And then there's things like Fleet, which is the simplest way to put it is it's kind of our equivalent to the GitOps workflow type stuff for Rancher. And then what we've done with RKE2 is we've tried to make it more in line parity-wise with Linux. So RKE2 is container D only, so there's no Docker. With Kubernetes 121, they kind of had the Docker shim in there, and they've dropped that out now, so it's all container D based. So we've implemented container D for Windows containers on RKE2, so you'll know that you'll be doing the most up-to-date upstream stuff. And we also use the Calico CNI to start with. There may be other CNIs added as time permits or as demand happens. We have a few kind of on our roadmap in our team GitHub repository that you can go see. And then we are anticipated for GA there in 2022. And I would encourage you now to check it out and start using it, and give us feedback, because we already have a lot of community issues coming in with people finding some small edge cases or improvements. We've accepted some community PRs for Windows stuff right now too. So this is a good way to get involved. Would be get involved now, and get us stuff early so we can make it for the GA release if there's something that you need in there. And then So I've kind of touched on the Windows containers for RKE 2 and Rancher 2.6 already. These things run as native Windows services. So right now we can't, without host process container support baked into Containerd and the Windows kernel, we can't really run things as pods currently. But our plan is to bring that functionality into the into newer versions when we can. So that way you'll have more parity with Linux and the capabilities there. So the slides aren't always updating on me, but if we can go to the provisioning and Containerd slide, I'll talk about that a little bit. So we have provisioning v2 coming. So I don't know if you're familiar with Rancher or not. So we've had the current provisioning prior to 2.6, and then we have the v2 provision. One of the things we used to do with RKE 1 and the older provisioning was you had to choose up front if this was going to be a cluster that supported Windows or not. And typically if it was capability, so that's something that we've changed, is in RKE 2, provisioning v2, you can now deploy a cluster and then add a Windows node at any time to get the Windows capability. You do have to choose Calico as your CNI, which is the default in Rancher to get Windows support. So just keep that in mind. And then you'll also be able to do some other custom configurations and stuff in the UI that should be easier to find and easier to do in choices. And it'll come up later in the demo, and I'll walk you through that one. And then we have some C API integrations coming. There's lots of Helm stuff. That's the things. So Containerd is going to enable a lot of cool stuff, and we're trying to keep up with our releases up to date as possible, so we can get those features in as quick as possible. And so that's we do have Containerd snapshots working on Windows. That's something you care about. And like I said, host process support is in Containerd now. It's not released officially yet. But when that does, we will get that added in and start trying to leverage that. To be patient if you're waiting for certain types of things to be supported, because a lot of times we have to relate on upstream to produce Windows images for on our adoption of some of these things. Like some of the CNIs may or may not have Windows images ready right away for host process container support. One of the things you'll have to keep in mind is that since we can have mixed workload using node selectors or affinity selectors, so that way you can select on the operating system type. So you'll see that some in the demo today where I want to deploy a specific thing to make sure that that gets deployed to a Linux worker. And then for Windows, I'll do the same. And that's just going to be something that's you can do in the UI when you're deploying a chart. If you know it's only Linux only, or you know you only want it to run on Linux, you can add those in. And then it'll schedule the chart and deploy it to whatever meets that OS type, which is good. And then there's Helm integration in the Rancher UI, which I'll show that when I install Traefik. So that'll be cool to see. And Fleet, right now, we have some ideas around some improvements we want to make there and some things we want to do for Windows to make sure that that's a seamless experience. Again, a key player here, especially when you start adding mixed workloads. And then everything natively in Go. So we've tried to make that more seamless, and all the Windows stuff is right there with the regular RKE2 code base. So that's as integrated as possible. We're working, you'll be able to just upgrade your clusters from the UI when you're ready to the new version. And then That's part of the integration of the Rancher system agent. So that's what is used now to upgrade clusters. That's coming in 262 or 263. That support and that capability. And then network policies, of course, you can use those now with Calico. Those work. Calico is something Microsoft's working actively to integrate closer into Windows, and especially some around the network policy support. And then Microsoft is also looking at adding eBPF, which was like a little note on one of the other slides. That's going to be really cool to have in there. That's bringing a critical tool set from Linux to having. So that's going to be cool to see that there. BGP, we're looking at BGP support. Calico offers that. So we are actively working on what that means and the best way to configure that for most people. So that's a thing. If you're a BGP, love to get feedback. So if you could go to our Rancher/Windows on GitHub and just drop a issue in there with your BGP usage and what you use. Do you use Calico now with BGP? Things like that would be really great to kind of let us know. And then we can jump into the demo. So I'll share my screen here. Okay, so what we have here is the GitHub link to the sample application. This is a .NET application written in .NET 5. It is using SQL Server for the database, SQL Server for Linux, but we are going to build the .NET application for Windows. There is a Docker file here right now that if you checked out this repo, it uses multi-stage builds. You can just do a Docker build and it'll build it all. You don't even need .NET installed. If you're on Linux, it's going to build you a Linux container. If you're on Windows, it'll build you a Windows container. Just know that if you're running your own cluster, you may want to add the tag specific to the version of Windows that you actually are running in your cluster. So you can find those tags on Docker Hub if you go to the .NET SDK or the .NET Runtime repo. So this is the Docker file. You can check this out. You can run this locally. There is a Docker Compose here just to kind of keep it simple to test some things. And then we have the manifests here for the different parts. So you can deploy your database and your application, and then Traefik for your Ingress. And I already have a Rancher cluster up and running. So this is all running locally for me with Vagrant. I have another repo out there with some Vagrant setups to deploy RKE2 or deploy Rancher. So if you want to check that out and you have Hyper-V, you can run that. Just be aware it takes a lot of RAM to run some of these clusters. So I've already went ahead and created a Traefik cluster, but first, this is kind of the new UI. So if you just click create, you'll need to select over here RKE2, and then you can do a custom cluster, which right now that's what we support for Windows is a custom cluster. And then you can come in here, you can name your cluster, and then the default networking provider is Calico. That is already configured out of the box to support Windows nodes. So there are some Calico tweaks required for Windows support. We have set those in there as default. They have no impact really on Linux clusters, but it does allow you to be able to add Windows nodes in and have everything work. And then you can choose your Kubernetes version. So we didn't start supporting Windows on RKE2 until 121.3. So this is 121.4. I would say use the newest version that you can select to get the best support, because we're constantly making improvements in additions. And then one thing I did for my cluster is I turned off metric server just to take the load off. And then I turned off the Nginx ingress. So that's something we do by default. I'm going to use Traefik here, so I'm going to turn off Nginx. So I have this cluster built, and you can see here I have 3 nodes. I have a Linux worker, a Windows worker, and a control plane. I need to go over here to Explore Cluster. And then we can look at my nodes. So I have these nodes. They're all running in Hyper-V as VMs, right, with Hyper-V networking. So I have a control plane, which has the API server and etcd installed. I have the one Windows worker and the one Linux worker. And I don't have anything installed in here right now. So if we go look, I have no pods installed as me. If I clear out the namespace, there's some stuff in here, the Calico, Fleet, the cattle cluster agent. So a lot of this is Rancher specific stuff, the Tigera operator that's used for Calico. But we'll just limit this to my namespace, to the default namespace. And then what we're going to do is we're going to go over here. We're going to go to chart repositories, and we're going to create one, and we're going to call it Traefik. And then you can paste in the URL that's in the Getting Started docs for the Helm chart repository here. And then we can click Create. And you can see here, it's now, I misspelled that. Here, let me edit that from here. Yep, can't change the name. Knew I'd mess up the demo. Anyway, let's hope that's all it is. So I've added the Traefik repository now. That is now bringing in all the Traefik charts. So if I go to charts and I can go up here and I can search for Traefik, you can see it's here. And then I can just click install. And then I'm going to make sure I don't type this incorrectly this time. So I'm going to name the chart deployment here, and then you'll get a chance to, in the UI, to edit the values, and we'll need to do that. So since I have a mixed workload cluster, I need to add in the affinity to tell Traefik to only deploy on Linux nodes. So I'm going to edit that there. So this is using the kubernetes.io/os label to say if it's Linux, you can schedule it to work there. And then the other change I need to make, since I'm not in a cloud environment with a load balancer, I'm going to change this to node port. And that's the only changes I need to make. So now I can click install. And you should see a console pop up where it starts running through the installation. And you can see here, it's now installed. So that's great. I got Traefik running. One of the things in the quick start guide is to, hop on over to the dashboard. So I need to go ahead and get my proxy started for that. I'll do that now. Now, if we go to the Traefik dashboard, there you go. We can see our services. These are all internal services for Traefik. And we can see our routes set up. So if I go to /dashboard, it'll take me to the dashboard. I can go to /ping or /metrics. And those will all work. So I have my dashboard pulled up. So now we should deploy our application. So let's close this. So there's a couple different ways to do this. You can navigate through here. I find it easier just to say import YAML. Now I can go copy my database deployment. And so I'm doing a deployment of AdventureWorks. So if you're familiar with Microsoft, they produce this sample database called AdventureWorks. I've containerized that. So I have a repo out there called AdventureWorks in my GitHub that shows you how to download the DAT files from Microsoft and actually restore those into a SQL Server for Linux and then produce your own container. So this is good for demo applications that you want to pre-seed with data and then build a container. So I just did this with AdventureWorks since it was already out there. The only thing special here is I'm just using the 1433 standard port for SQL Server, and then I yet again do have an affinity set up for nodes to deploy on Linux because Microsoft only produces SQL Server images for Linux containers. And then I'm creating a service to expose that out. So we're going to import this. Service is already active, not much to have happened there. What's happening here is it's pulling the image. So the Rancher UI is really good for that. You can kind of see the conditions. You can see recent events. So if we kind of watch this, you can kind of see what's going on inside your cluster. So it's pulling and creating a container right now. So we'll let that get finished. If you got any questions, feel free to ask. As we go, post them in the chat if you want. I'm watching that too.
So what were some of the challenges you had in building this demo, Jamie?
I think a lot of the challenges were around the typical things, getting the containers built for the right host systems. Specifically Windows, right? Like I'm deploying this on 2019 server. I needed to use the Nano Server 1809 image to do my build from. I don't know what the default Microsoft chooses if you just use the generic tag. I still haven't figured that one out. So that was kind of an interesting thing that even surprises you sometimes. And then the other things really comes down to just understanding how networking works inside of Kubernetes, because you have to have your app talk to the database. Is your DNS working correctly? Do you have connectivity between your pods? Is your CNI configured correctly? And then figuring out, it's been a long time since I've looked at Traefik, and there's been some changes and new guidance around how to do things, which I think is much easier, by the way. But that was just, relearning some stuff that I kind of knew 2 or 3 years ago that, if you don't use on a regular basis and it changes so fast, it's kind of hard to keep up. So that was one of the hard parts. The other part comes down to Windows apps and trying to build cross-platform Linux and Windows, or at least writing your Docker file to where they work. There's some oddities. They've kind of ironed some of those out, but like the early days, file system casing wouldn't get correctly generated by a .NET new app, and so you would have, Windows doesn't care, it's not case sensitive, Linux is. So sometimes your files will get named with a lowercase, but yet when you write your Docker file you use an uppercase, and then you're trying to build for Linux and it doesn't work, but it works on Windows. I run into a very similar situation where a build would work fine on Linux but wouldn't work on Windows for this app, and I had to rewrite my Docker file and restructure it a little bit. So typical things that are just small differences that you don't think about, especially if you're coming from Windows going to Linux. The case sensitivity part is always a big one that ends up impacting you. And then Git doesn't really care, right? It's lowercase, uppercase, file name. It just acts like no big deal. It's a hard one to track down that you just don't realize is going to happen until you start trying to build your containers. So we have this deployed now. So that's good. And then I need to deploy the app. So let me copy that over here. Sure, I don't have a copy paste error. Trying to get this into the UI here. So now I'm going to import, and I'm going to yet again deploy the app. This time I am only restricting this to Windows because this is a Windows image for this tag. That's the only thing I pushed up. I could have pushed up a Linux version and deployed a Linux and Windows version. Might be something I'll do in the future. These annotations don't really matter. They're not needed. This is when I do some experimentation. So now this one will take a little bit longer to deploy, right? And the big reason is it's got to pull the Windows image. So you'll see here in these conditions or events, it's pulling the image. This is by far what's going to take the longest, right? This is using Nano Server, so it's only about 600-700 megabytes with the .NET runtime and the .NET app in there. Just be aware that they do get up into the gigs. If you use Windows Server, that's 3.6 gigs, 3.3, somewhere around there. So just be aware of that when you're picking your base image and what you need. Try not to go larger than what's required for the app because that will affect deployment times. But once the image is pulled down, you get all the benefits of the caching. So the next deployment will use the same shared base layers and speed that up. So now this is deployed. So that's good. So this app's up and running. So now if you look over here, you can see as far as my pods go, I have my database pod, I have my app running on Windows. Now I need to deploy my Traefik setup. And I'm using Ingress routes for that, which is my understanding, and it may be incorrect, that is the preferred way to do it now, which I will have to say is much easier. So I'm going to deploy this at the root of what traffic is exposed. I could probably subpath that. Be aware if you do subpath it, I didn't set up the default ASP.NET Blazor app doesn't have that accounted for the root to be different. So that will be a tweak that needs to be made to the app if you wanted to run it on a subpath. So that is done. And now if we hop back over to the Traefik dashboard, you can see here that I now have 6 services. And you can see here's my apps deployed just fine. So now if I go to the exposed Traefik endpoint, and we should have our app pulled up. And there we go. There is our Blazor app running on Windows, connecting to a SQL server on Linux, using Traefik as ingress. And then to prove that the database works, I clicked sales report. So now I've queried out of the sales info out of the AdventureWorks database and rendered a bar chart. And then I went one step further and decided to make a map. So this pulls out all the retail locations for people that sells AdventureWorks equipment around the globe. So, and this is all using Blazor. So Blazor is Microsoft's C# in the browser WASM thing. This is server side Blazor, so it's rendering on the server before being served. But that is one use of Blazor, is you can compile C# to WASM or WebAssembly. So that's what this is all using. And then there's links to different things here, the different technologies used to do this. And then the About page takes you to our GitHub repo, where I was telling you to go to file issues. And you can see here we have some of our roadmap items out here, things we're going to work on. Most of it's categorized in a way, and then we have some community contributions actually coming in on individual repos, and then some things end up here. But if there's any feedback or anything you want to know, just pop it in here as far as RKE2 goes, or Rancher, and Windows containers. So is there any questions? Anything? Okay. For .NET Core. Yes and no. As far as so the question is, for .NET Core, probably doesn't really make sense to run on Windows. That's true, unless you consider that maybe you have Active Directory integration, right? And the only way you're going to get Active Directory is with a Windows container doing GMSA accounts. Switches, some things on our roadmap to make easier and to work better. But that's one particular use case that would definitely come into play for .NET Core unless you decide to use LDAT for your application, which would probably be what I would recommend if you're doing .NET Core, right? That's generally the guidance. But I'm sure there are some Windows APIs that you might want to use in .NET Core that you can only use the Windows extensions for, the Windows libraries for, and then if you want to use the Windows API, you're going to have to be on the Linux container, right? So some people might be straight porting their .NET Core, .NET full framework application to .NET Core. They have specific dependencies on IIS or some other type of dependency that they need the API for, and they'll need to run on Windows, right? So there are a need for Windows containers for .NET Core even. When it comes to like legacy apps and things like that, that gets a lot trickier, right? Because some of them are not going to be able to be ported. I'm saying legacy apps. I should clarify. I'm .NET full framework applications that maybe you think you can port to .NET Core, but they have a weird dependency on Windows APIs. I've actually, so this is not .NET related, but I've actually helped somebody run Oracle e-business suite in a container. So that's in a Windows container at that, because the front end needed to run in Windows. Don't ask me why. It's those weird dependencies where people add custom code, they call some Windows feature, or they need a GDI library, or they need to integrate with Word, right? And that's only going to work from a Windows box, right? So I've helped with that, and that's been quite a few years ago. Most things, in my experience, typically work. It all depends on what you're doing. And as far as legacy apps go, you have to know your application, right? And you have to know what's in there. You have to know what you used. You have to know your dependencies. I ran into apps trying to containerize that required libraries that could only be installed with GUIs. So you can't really install that into a container. Coming to find out, you could hack the registry. So you could just pop the stuff out on the file system and do these really obscure registry hacks to make it work. But in general, it comes down to what your dependencies are, knowing what they are. Can they be automated? Can they be installed? Can you substitute something on Linux if you want to run on Linux? I mean, that's really the thing about Windows containers is what you're there for, right? Is you're there for the Windows API for IIS if your app needs IIS. So you're really there for those things, right? And maybe you have some PowerShell that needs to do something that needs Windows libraries, and so your web app is a wrapper around PowerShell, or maybe you're using Pode or Polaris to run a PowerShell web app for some system admin stuff, and you're probably going to want to run that in Windows. Maybe NanoServer may not work. I don't think there's NanoServer equivalents for WMI calls from PowerShell. So just throwing it out there. Like there's things that you're going to want to do, or you may need to do, that Linux is not going to support.
Yes, absolutely, Jamie. Wonderful session. Finally, I see a very long time how to run .NET apps. And the Blazor is the last time I see, I think 2018. And the Microsoft came up this technology, and that I see the WASM is everywhere popping up. Even you've been in the service mesh space, that's invoice using the WASM filter and these kind of stuff. So I think it's a wonderful session for me. I have learned a lot. I see some of the question, and Hayden has asked a few of the question. So I try to ask some question around that. I will see that Windows container right now is getting more the mature, because the first thing is came up the people mind how to minimize the image size of these container. So I think the first question, and then we see that right now people came up with a solution to minimize the images of these containers. And the next question is, you see that it's a very smooth experience on running Windows container on RKE too. That's a wonderful news for me. So the next question people asking about that, is there a Windows, we see the containers that came up with so many other solutions came up, like say Prometheus for the monitoring solution, then the storage has some other solution, then we have the traffic proxy, Do Windows have these kind of support, or do Windows leverage these already built in open source distribution, open source projects from the CNCF Foundation, to build out particularly these tools for the Windows container in the moving forward? These are the question people are asking about right now, because as the containers are becoming more mature in more matures than ever.
Yeah, so you're asking, like our CNCF project starting to support Windows containers? Well, I can tell you, Traefik does. Traefik has Windows containers. I don't think their chart. I don't know. I didn't really try, because there's other things that come into play when you're trying to run certain services on Windows, right? And host process containers, I think, is going to open that up to where more projects feel like they can produce Windows containers for their software and have it actually perform or work the way they want it to, right? And until we have that parity there, I think sometimes you run into lots of odd behavior that maybe is not expected. But Traefik for a fact actually does produce a Windows image, so you can run this as a Windows container, Traefik. So that's a good point. A couple others, like a lot of stuff we produce, all has Windows support for the most part. There are limitations due to upstream, but that's getting better. That's getting better every day. More and more things are getting, more and more of the underlying technology in Go is getting to where it'll be cross-compiled for Windows and for Linux, so that way you can then make a Windows container for it.
Yes, absolutely. I see the Rancher's repository. They have a lot of stuff for the Windows container, not just for the Linux. I see everything and new tools is built up for supporting the Windows kind of things. And I think the Rancher are doing wonderful move for the Microsoft ecosystem as well, because Windows container right now people are talking about, because people like you are who have this kind of experiences managing and configuring and installing these systems on the Windows machine and don't have enough time to manage these on the Linux machine. So they are very happy to see the Ranchers or ecosystem or adopting to Windows container. So one question from Hayden is from me is, I see the Rancher 2.6 coming up, and what can you explain to us what's new in it? You explain a lot to us that there are so many good things in eBPF kind of things and some other you have mentioned here. So can you elaborate this on more detail, like what is new in the Rancher 2.6 and what is the best things you see in the Rancher 2.6?
So my favorite feature in Rancher 2.6 is the Windows container support on RKE 2 has landed in tech preview. So that is there and ready for the community to try and break and file bug reports on and feature requests and help guide us forward on what you would like to see. Is there specific CNIs you want to see? Is there specific apps you want to see supported? That is why we are getting out there and talking about it, even though it's still in tech preview and won't be GA until the spring. We want to get this in the hands of users, start using Windows containers, push the technology, give us feedback so we can improve it. Now, other things in 2.6 that are there, we've got new cluster provisioning capabilities. We have a slew of bug fixes. Fleet, our new GitOps functionality is built in. The release notes, I worked on the release notes. The release notes are just chock full of all kinds of enhancements for AKS and EKS and GKS. So if you're deploying to the cloud, we're getting more support for that. We have support for more of that coming for Windows containers, but generally that support is very good on Rancher 2.6 and has gotten better. So I would encourage you, the great thing about Rancher, the product, is that, and the company in general, is that it's all open source. So you can go to Rancher on GitHub and look at our release notes and see every PR, every issue, and even the messy parts, and see what went into making that software and what the latest there is. So if there's something specific to Windows you want to see happen or feedback for us, we have our GitHub repo Rancher Windows, which we've mentioned a few times, and that's the place to reach the Rancher Windows team directly. And we monitor that closely, and bug reports, feature requests, the key thing is that, we have an idea of what we think, the community wants and users want and our customers need. But in terms of, how we allocate the amount of time we have, if we hear from a lot of users, we want this one specific issue, that helps us prioritize that and get that done faster. So we can't do that until we actually hear from users themselves. So filing those issues, making those feature requests is super helpful, even if it's, even if it's not a detailed bug report with steps to reproduce, even if it's, I just want to see this, we want to hear it. So, we develop in the open, messy bits and all. So please give us that feedback. We really appreciate it.
Yes, absolutely. And one of the best things I see from the Rancher community, they're open to the community, open to the feedback of the community. They're really looking at critical what the community thinks in the future, what's the community thinks about the Rancher project. That's a wonderful news for everyone, because they are closer to Rancher community, and the Rancher ecosystem is closer to the open source, closer to the people, closer to the community. That's a very wonderful news. I see a lot of the stuff we've seen they're closing and looking at the open source solution that people are developing, and then integrating those up into the Rancher repository and Rancher ecosystem. But today I'm really learned a lot. So for a very long time, after I'm finally able to learn the cloud native .NET apps, .NET is the first love for me for a very long time. I'm still figuring out the .NET releases, what's happening inside the .NET ecosystem. Jamie, thank you very much for a precise demo on, and I really appreciate everyone who joined us today. And Hayden and Jamie both are in the Twitter, actively on the Twitter. If you need any question, needs any thoughts about the Rancher or Windows container or WSL or any other kind of issue, feel free to reach out to Hayden as Unix terminal. And I think Jamie Phillips as Jamie. I'm missing out your Twitter handle. Can you tell us?
Yep, it's Phillips J73.
Yes, Phillips J73. You can reach out to both. They're actually answering your question on Twitter. And hope to see you again in the next webinar on Traefik Islamabad. And thanks Hayden, thanks Jamie for sharing your knowledge, sharing your time with us. It's been a very long time to connected you. Finally, we have this a wonderful presentation on Rancher 2.6, .NET, Traefik, and these kind of stuff. So won't take much of your time. Bye-bye, everyone. Stay safe, stay healthy. Hope to see you again in future.
Thank you.